Today is our Emerging Technology Track Day, and we've got a variety of great talks in our breakout sessions, but we also have a great keynote this morning, Hunter Pendergrass from MIMIR Technologies. For those of you unfamiliar with MIMIR, I highly suggest you take a look at their company and what they're doing. It's really incredible, the whole background of the company and everything that they're building. So without further ado, I'd like to introduce Hunter. If everybody could give him a quick round of applause.
My name is Hunter Pendergast. I am the CTO and a founding partner of MIMIR Blockchain Solutions. We are an Atlanta-based design and consultation firm. We build systems that allow companies to leverage blockchain technology. We have also been building a set of core developer tools that will allow other developers to leverage the benefits of blockchain technology without all of the complexity that we've had to face. Finally, we build cryptographic systems for secure communication and data distribution. I appreciate you spending your time listening to me speak this morning, and I hope you walk away with value gained from what I'm about to say. I'm not going to try to convince you to send me thousands of dollars in cryptocurrency with the promise of future benefit. I am going to try to convince you that enterprise businesses can leverage blockchain technology for benefit today. Keep in mind, these solutions are not a magic bullet. These solutions will take time, and this should come as no surprise. Tech takes time. Specifically, ubiquity takes time. Just as computers shrunk from the size of a room to being held in our hands, just as streaming services went from a niche internet-savvy audience to coming pre-packaged with just about every television on sale these days. Just as we now tell someone to Google it when they don't know an answer. Ubiquity takes time, but once it has arrived, ubiquity is the holy grail of disruption. This may surprise you, but blockchains are complicated. Understanding how to properly utilize blockchains may be even more difficult than building them. The good news is not everyone needs to understand blockchains for them to become ubiquitous. Developers view blockchains as a means to build a censorship-free internet where you pay for what you use instead of selling your identity to gain access to services you desire. Enterprise views blockchains as a means to reduce cost around administration, compliance, and coordination. Both of these views are valid, even if slightly at odds. But the big question is what comes next. When trying to see the future, I often look to the past. To better understand where we are today, I'll use the Linux operating system as an example of how open source technology and industry can work together for mutual benefit. On initial inspection, Linux and blockchains have almost nothing in common. But what I want you to consider is that there may be some potential similarities. Building an operating system encompasses many things: security, coordination, data protection, and allowing many programs to share resources seamlessly are just a few of the hard problems that need to be solved. Blockchains perform the same kinds of operations across thousands of computers instead of across dozens of programs. This kind of coordination is no easy task. When trying to describe how difficult the problem of coordination truly is, I like to reference a famous programming quote. This quote is actually a comment from the Unix source code that says, "You are not expected to understand this." Fortunately, programmers do not have to understand every detail of the context-switching algorithms that drive their operating system in order to build programs that run on them. Similarly, developers do not have to understand every detail about asynchronous consensus algorithms in order to derive benefit from them. Linux is an open source technology built by thousands of collaborating programmers, engineers, hobbyists, and scientists over the course of more than a decade. The result of this effort is evident from the nearly 70% of all public web servers, 70% of mobile devices, and nearly 30% of embedded devices running on Linux or a derivative system today. Blockchains are almost entirely open source in nature, and the core technology around them has been built by hundreds of programmers around the globe. Like Linux, blockchains are an infrastructure technology that will allow programmers to create new systems that were previously impossible or at least impractical. This is a point I would like to stress. Blockchains are infrastructure. They are an infrastructure that could become an industry standard around data integrity and authenticity. And while that may not sound as exciting as some of the promises of some proponents of blockchain technology, it is an incredibly important fact in a world that treats electronic records as fact. The lessons blockchain can take from Linux are readily evident. Build quality tools that are general purpose. Make these tools universally available, and they will become ubiquitous. Enterprise businesses will reduce cost and improve efficiency by utilizing these tools, and in turn, developers will be rewarded for their efforts. Everyone benefits. I'm sure many of you may think I'm idealistic in this expectation, but in spite of the open source nature of Linux, we've seen it become a successful enterprise model. In 2008, the Linux kernel was estimated to be worth $1.4 billion US, and Fedora 9 is estimated to be worth over $10 billion US today. Blockchain is an infrastructure that, like Linux, does not require the user to be an expert in order to derive benefit. That said, if you are banking on the everyday user understanding and abiding by best practices of OPSEC and private key securities, you may want to reconsider your business model. This is not where blockchains shine. They still require the user to understand asymmetric cryptography, or at least how serious the matter of protecting your private key truly is. Where blockchains shine is in protecting data. Blockchains stand between the user and information. Blockchain done right, like Linux done right, will serve as the invisible layer behind tomorrow's disruptive technologies. The key to achieving this collaboration is building tools in an open source manner. Although open source may not be the standard in an enterprise world, many tech giants have already accepted the necessity of blockchains to be open source. For example, IBM has released nearly all of the code it developed around the Hyperledger project. This allowed other programmers to improve on the platform, and IBM has been able to embed those improvements in its own offerings. Something as seemingly innocuous as allowing users and programmers to view the source code behind a program does something truly amazing. It allows programmers to take risks and experiment. Sometimes this only means a little tinkering, but sometimes the end result of this tinkering is something entirely new. Just like Ubuntu, Red Hat, and Android utilize Linux to build their platforms, developers will do the same with open source blockchain technology. So, those of us already in the field of blockchains, you might be wondering, what have we been doing? We've been experimenting. The end result of this experimentation is the maturation of the blockchain space. We are moving past white papers and future promises and beginning to see the utility of blockchain technology. We are seeing the regulation of the ICO. We are seeing the consequences of leveraging this technology to con others out of hard-earned money. We are also seeing this technology hold institutions accountable for their actions. The United Nations is a prime example of using this technology to provide accountability. In 2017, the United Nations leveraged the Ethereum blockchain to ensure funds distributed to Syrian refugees reached the people those funds were intended for. In 2018, we saw pilot projects that could trace a piece of food all the way from the field to the shelf in a grocery store. It is no wonder the CDC is looking at this technology as well. The ICO boom may be over, or it may be just gentrifying. Either way, you should know that pivoting to chase the new killer distributed application isn't the only way to utilize blockchain technology. There are immediate applications of this technology that go beyond token sale hype. The most promising places to look are readily evident. Public record systems, digital identity, cryptography, healthcare systems, supply chain, and even governance can all benefit from the work that has gotten us here. In order to gain perspective, let's take a step back. What is a blockchain at its core? The often quoted term of an immutable ledger comes to mind. And while this is not inaccurate, there is a more fundamental concept at play. Blockchains are essentially a clock. They tick away one block at a time, and with each tick, a new global truth is formed. Order is important. I would love to claim to be the origin of this statement. However, I know I am not the first to say it. If you don't agree with this idea, try baking a cake by following the recipe from end to beginning. I doubt you will get a cake when you are done. Blockchains allow us to agree on what the state of the world is by allowing us to agree on in what order things have occurred. When we put code in this database, we have the foundations for a global computer. This is what allows smart contracts to exist. Smart contracts are the mechanism by which we can abstract the benefits of a blockchain to new, unforeseen applications such as data authenticity. Although blockchains allow data to be authenticated, they are not a database in the traditional sense. Rather than store the actual data inside of them, they are a place we put the smallest kernel of truth that is necessary to secure the rest of our information. This could be, for example, a public key, an IP address, or the hash of a piece of data. We only put the smallest amount of data needed inside of blockchains because they are slow, expensive, and redundant. We accept these faults because blockchains are a system that enforce rules. These rules prevent unauthorized modification. When coupled with cryptographic hashing, the rules of blockchains prevent someone from being able to successfully lie about the past. Rather than calling a blockchain an immutable ledger, I like to view them as a clock with one of the best permission access management systems the world has ever seen, even if that sounds far less appealing than a distributed ledger. Allow me to use another example. The internet, much like your car, requires keys. Your keys allow your car to know that you are either the owner or at least someone who has had access to the owner. The keys of the internet are very similar. They allow your computer to know that the server it is talking to is either your bank or at least someone who managed to get into the digital systems of your bank. This leads us to what is probably the most important promise of blockchain technology. In both the instance of your car and your bank, if you lose your keys, you should probably change your locks. While this is simple in the physical world, it is far more complex to do in the digital. The way keys work in the digital world is based on trusted third parties signing your public key. By doing so, this third party is stating that you are the entity you claim to be. The problem is that once someone has one of these proofs, the proof will keep working even after you change the metaphorical locks. To limit this harm, these proofs are issued for a finite amount of time, but this only limits harm. It does not necessarily prevent it. Blockchains can make this system better. They can create a world in which an entity can nearly instantly change their digital locks. What I've been talking around is TLS, or Transport Layer Security. As I'm sure many of you are aware, this is the cryptographic backbone that facilitates the modern world doing e-commerce in the manner that it does. Like many of the other businesses I've discussed today, the common public probably wouldn't consider them to be the most exciting things on the face of this earth. But in 2010, VeriSign sold its authentication division to Symantec for approximately $1.3 billion US. Although it may not be exciting, it is at least apparently lucrative. And this should come as no surprise when you consider what these systems protect. The global e-commerce market has been estimated to be worth $22 trillion. This is also a strong reason for improving these systems where practical. In order to understand why these systems could benefit from blockchain technology, I would like to once more look at the past. In October of last year, a Brazilian bank with assets that exceeded $27 billion US lost control of their digital identity. A group of hackers stole it. While identity theft is a reality we all live with due to any number of data breaches from the last year alone, we rarely hear of corporate identity theft. This by no means implies it does not occur. The result of this loss was thousands of credit card numbers, user credentials, and an unknown amount of actual currency. Although the bank was able to regain control of its own systems within 5 hours, a terrifyingly long time, the persistence of this malware was much greater in duration and potentially more widespread. Many of the users may not have even been aware that they needed to update other credentials not associated with the banking system itself. The result of this attack against a single corporate identity was that thousands of other systems may have been indirectly compromised as well. I'm sure many of you have already realized this, but in this instance, the bank itself did nothing wrong. The bank was not compromised due to bad security practices. The bank was not compromised due to using outdated software. The bank was compromised because of an external actor for which the bank had no mechanism of control. As a group of industry experts, I am sure you will all appreciate how terrifying this truly is. How many of your own systems depend on external systems? How many of your own systems could be subject to the same attack? How many of you have even considered the threat model described and how you go about recovering from such an attack? Terrifying indeed. Blockchains may be a mechanism to do better and allow for greater security. The benefit of an immutable record of state, one that is temporal in nature and protected by strong cryptography, has immense potential to improve these systems. Namecoin is an existing system based on the core technology of Bitcoin for this exact purpose. Namecoin allows a user to register a web domain without the need for an external central authority. Another great example is the ENS, or the Ethereum Naming Service. This is a system that leverages the smart contract capability of the Ethereum blockchain to build a DNS system inside of smart contract logic. My own company, MIMIR, has launched an example of how to build a practical implementation of a real-time revocable PKI. This system was built on the Ethereum blockchain and leverages smart contracts as a means to solve the key escrow problem associated with encrypted messaging. This service is named ETHMail. The commonality of all of these systems is the benefit of not being dependent on a central organization, which may, at some point, become compromised. The downside is, of course, if you lose your private key that is used to access and modify blockchain resources, there may be no mechanism of recovery. Let me reiterate that fact because it is so important. If you lose your private key, there may be no mechanism of recovery if you are utilizing blockchains. In order to combat this possibility, many companies have been building something called threshold multi-signature access control systems. For those of you who may have fallen behind on the hip trends in cryptography, these systems allow a private key to be split into many pieces, such that it requires some arbitrary subset of the pieces in order to construct a valid cryptographic signature. When we build these systems on smart contract-enabled blockchains, such as Ethereum, we may programmatically layer policy-based permission access management controls in a Turing-complete programming language. In simpler terms, we can create policies to control policies. We can build threshold systems that allow us to revoke a key in near real time without the need for a blacklist. We can self-administer the digital identity of our systems and use the same digital identity to control our DNS services as well. Finally, through multi-signature access control systems, we can create break in case of emergency keys that allow our organization to recover from the loss of control of a digital identity. All of this can be accomplished without external centralized systems. In spite of all of the potential, we may be years away from adoption of these systems in the infrastructure of the internet at large. There are massive changes that need to occur to transform legacy systems. This does not mean that these concepts cannot be leveraged today. Private infrastructure depends on the same principles of operation as the public internet. Many of your companies leverage private certificate authorities and DNS systems for private networks. The value of changing existing systems must be based on decisions of cost, complexity, and added benefit. For many, the cost does not outweigh the benefit. For some of you, it may. In order to evaluate this decision, consideration of risk and benefit must come first. The risk is clear. According to Verizon's 2018 Data Breach Investigation Report, systems administrators are the top internal actor in security breaches. Further, system administrators are involved in nearly 26% of data breaches. This involvement may be through bad practices or malicious intent. The benefit is also clear. We may construct systems with no single point failures. We may limit harm. We may rapidly revoke and reissue credentials. We may even prevent an action from occurring without multi-party approval. These are substantial improvements to existing problems. I've been discussing the ability to configure infrastructure through the application of blockchain technology. This is not a new idea, but I would like you to take this idea and extend it to its natural eventuality. Given that we are capable of utilizing blockchain systems for coordination and configuration of data that is internal to the blockchain, may we also utilize them for control of external systems? The answer is yes. I know this is possible because I've built systems that behave in this way. There are other companies working on this technology, but none of us have taken the necessary step of open sourcing our code as of yet. If these technologies are to become ubiquitous, collaboration will be key. The minds we will need in this collaboration are sitting in this room, and the reasons that should motivate your collaboration are evident. These systems enforce an immutable record of all administrative actions taken within the environment. I am sure many of you can appreciate the potential benefit to compliance audits this record holds. These systems may be one of the best defenses we have against one of the biggest threats in the information technology industry, the internal actor. In spite of all this potential, blockchains are not a magic bullet. They will not solve everything. They have been used for great harm, and they will most likely be used for great harm again. We have also seen them leveraged for great benefit. The mechanisms of this benefit may allow them to underpin some of the most critical infrastructure of tomorrow. This is because, ultimately, blockchains are infrastructure. That's not a bad thing for enterprise, and it's not a bad thing for developers either. Some of the hardest problems exist in building infrastructure, and in the solutions, profits will exist. So what does this mean for the people of this room? What does it mean for the people of this city? We are all standing on the cusp of a new wave of innovation that will transform our digital world. This is a transformation that does not care if you are in London, New York, San Francisco, or whether you're ITP or OTP. This is a transformation built on the promise of allowing businesses to engage each other from anywhere in the world. Atlanta is building for the future. You see it everywhere. Roads, schools, communication systems. These are the infrastructure of society. Atlanta also has the ability to build the infrastructure that stands behind the next generation of digital systems as well. Thank you for your time. My name is Hunter Prendergast, and I'm the CTO and a founding partner of MIMIR Blockchain Solutions.